Hello, welcome back. This is indeed the last lecture for this course and for the year. It's going to be pretty short today. We're only going to do a short course retrospective, no new material or anything like that. But I do like to put an end cap on this course to review basically what we've done, what we've been through, and well, hopefully what we've learned. I do have the live Q&A feature on Piazza going, so if you do have some questions, you can go ahead and feel free to pop in. But otherwise, what is a retrospective? Well, in software development, you have what are called sprints, which is basically what I tried to emulate in this course. That each homework, each assignment, each phase was treated as a sprint. Sometimes sprints are 2 weeks, sometimes sprints are 4 weeks. It just really depends on the organization and what type of agile software development they're using. At the end of each sprint, you're supposed to give a retrospective. What went well, what didn't go so well, and what can be improved for next time, or what adjustments need to be made for next time. So part of that is the course evaluation. That's your opportunity to tell me your retrospective. What went well in this course? What didn't go so well in this course? And what could we do to improve this course in the future, both for my offerings and for other instructors as well. I'm not the only one that delivers this course. That's your opportunity to tell me. So I really take that seriously. I really take that feedback to heart. Make sure that it's constructive. Make sure that it's well thought out. And especially this year with the transition to remote learning. Hopefully next year in the fall we'll be back to normal, but at some level there will be some remote learning for some populations that are immune deficiency population students, or students that just simply cannot get back to Lincoln to attend class face to face. We will be the department and UNL at large will be trying to accommodate that as much as possible. That is our goal, and so giving that kind of feedback will be extremely valuable for us in the fall to determine what went well and what didn't work so well with regards to remote learning. To improve the response rate, remember we do have that bonus 15 points, which comes out to basically 1% of your grade with respect to the response rate. Right now, about half the people in the main section and about 2/3 in the H section have responded, which translates to everybody gets 8.16 points so far. So make sure that you are putting that in. Again, you don't have to do it right now. Once you're done with the last assignment, you can go ahead and do that. It does go till Sunday, which is May 3rd. So you do have until then to fill that out. Please do so. All right. So what did we learn? What were the lessons learned in this course? What were the skills that you acquired, etc., achievements unlocked, etc.? So I format this course as a project-based course and allow you to work in pairs because I want you to work on, first of all, those soft skills. If you did choose to work with somebody in a pair, then you had to, you got exposure to actual teamwork, where you had to coordinate with each other to say that we are going to meet at this such and such time, and we are going to work on it. And then you had to bounce ideas off of each other. Nobody works in a vacuum in real life in industry, and so you've gotten some exposure to more formalized teamwork by doing this. Let's see. We've got a question here. Let me go ahead and take a look. Does it go through a third party? No. Every instructor, it's not going to be released. So they've asked about, do I look at it directly? Yes. All instructors look at it directly. It's also taken a look at by maybe the personnel committee, as well as our vice chair and chair of the department. I believe that they might be aggregated across the college and the university as well. But every instructor does view their own, at least. I can't view other instructors, but I definitely look at my own. It remains anonymous throughout the entire process. If you're worried about that, even after it's released to me, I still never see who said what. So don't worry about that. And not only that, but it does take quite a while. So it closes in early May. but we do not get the results until late May. So it's way after final grades have posted. So don't worry about that if you're thinking about anonymous feedback. It remains anonymous for all time as long as you don't put in your own identifying. Hey, look, I'm John something, right? So back to the lessons learned here. You also may have, you might have had an ideal partnership where you worked together simpatico the entire time and you had no problems with each other whatsoever. But sometimes you might have had problems or the partnerships have dissolved, right? That's all part of the process, conflict resolution. Now, in a real job, you can't choose your coworkers, so that might not be an option in the real world. But you still need to have some sort of conflict resolution experience there. How do you deal with somebody who's not pulling their own weight? How do you deal with somebody who is taking too much control on the other end of the spectrum? That they're not respecting your input or respecting your ideas. How do you manage other people and other people's expectations like that? And also, it's again going back to remote learning here. Coordination. Hopefully, you've got a lot of that out of the last few weeks, because what you've experienced over the last few weeks is actually the ideal work situation. If you can work from home and not have to commute, right? That saves you money. That saves you time. It saves you distraction, right? The modern work environment, you have people coming over all the time and in your cubicle or in your office or whatever. Or maybe if you have God forbid, if you have an open office environment, then you hear conversations all the time, right? It's not very conducive to something that is a heavily mental process like coding where you have to get in the zone. And so working from home and also when it's time to come together for that teamwork, for that communication and that coordination, I'm glad everybody got practice by doing this remotely. Again, you might not be so lucky. You might be at an employer that requires you to be there at all times, regardless of whether or not you need to be there. But software development is one of the things that is perfectly suited for remote development and remote working. Hopefully, you've also expanded your toolbox. You've picked up a second, or maybe in some cases a third programming language. You will be doing that throughout your entire life. Even if you're in a job and you use one or two programming languages on a daily basis, never stop learning. Right? Pick up a new programming language, see how things go. Right? Hopefully, in Computer Science 3, when you move on, you pick up yet another programming language, C++ or Python or something like that if you haven't already. You need a large toolbox. Not that you're going to use these programming languages on a daily basis. Not that you're going to be an expert in 12 different programming languages, but you should be aware of other programming languages so that you can see how things are done, how problems are solved using different frameworks, using different language paradigms, basically, right? You've hopefully got, you've now have an object-oriented programming language. Lots of object-oriented programming languages do things very similarly. The big four, encapsulation, abstraction, inheritance, and polymorphism, they're achieved maybe achieved slightly different in other programming languages, but as long as you understand the concepts, then you can think, oh, well, how does this language, object-oriented programming language, how does it deal with inheritance? And how does it deal with polymorphism so I don't have to rewrite a sorting method over and over and over again? Hopefully you've also got now exposure to SQL. Unfortunately, a lot of curriculums don't introduce databases and database design early in the curriculum or even at all, which is terrible because you absolutely need that in any development environment. And so we've equipped you with those database skills, SQL skills that enable you to get an internship even after your first year. So never stop thinking about internships, even if they're remote this summer. Even if you don't know what the programming language is that they're going to be using, you can pick it up much easier now that you've got a second, third, fourth, fifth programming language. And hopefully you've been using Git this entire time. We don't enforce it, but of course you've been using it in all of your labs. We don't require it if you work with somebody, but as you've seen several posts on Piazza, there was a great post a couple of weeks ago where somebody posted that that their entire project was saved from deletion because their computer crashed, but they were able to recover it because it was all on GitHub, right? Exactly the point of one of the points of using a distributed version control system like Git. And so hopefully you're appreciating the value of these tools that you should be picking up and that you can use them going into the future. You've also had some more experience and perspective building a larger project. This is still kind of an artificial project in that we set the sprints, we set the phases, and said that you're going to do this, this, and this. Now, in a real project, you would have to make that planning yourself. That would be all part of the design phase, where you say, all right, we're going to need this component, this component, this component, and then you go and you plan out those components, how you're going to implement them. But so it's still not 100% realistic, but we've given you a kind of a taste of what a real project might be in the future. You've also been exposed to technical writing. Hopefully you took advantage of that design document that you were maintaining throughout the semester. Hopefully it gave you an opportunity to think about the design far before you actually implemented anything. Maybe design documents or requirements documents or something, all kinds of documents are not going to be a big part of what you're eventually going to do in industry or as a career. But it is something you should be aware of, and you should be able to take that communication skills, those technical writing skills, and apply them to other places. Even as simple as writing a simple email, right, in a professional manner, and getting directly to the point, rather cutting the fluff, cutting the cruft, all that kind of stuff. Again, you're not necessarily going to be doing that as on a daily basis, but also it gives you some perspective here that a software developer, a software engineer, whatever you want to call yourself when you get into industry, that coding is actually only a fraction of what you're actually going to be doing. A lot of times you're going to be reading, right? You're going to be reading documentation, or you're going to be reading something new, or you're going to be reading old code and trying to grok it or understand it, and that so that you can fix it, or so that you can refactor it, or so that you can extend it. A lot of the times, the majority of your time is going to be spent reading. A lot of the times, your time is going to be spent in meetings, fortunately or unfortunately. If they're good meetings, that's why we call them stand-ups, by the way. If I don't know if I've used that term in this course, but if you're forced to stand up, it forces you to get to the point so that you're not talking about inconsequential or irrelevant garbage, because everybody's standing, everybody wants to sit down eventually. So the stand-ups are intended to be get to the point, kind of like the technical writing. Get to the point with as few words as possible, with diagrams or something like that, but not too much, so that not too little, not too terse, so that the idea is lost. All right. Hopefully you have better appreciations for some of the things that we've talked about throughout the semester. Hopefully you have a better appreciation and understanding of technical debt, or eating your own dog food. Remember, technical debt can be summarized in plain English by saying either you find time to do it right the first time, or you find time to do it over later, right? Technical debt means that you do something poorly, you have a poor design, a brittle design, with a bug that may or may not be apparent. Maybe it manifests itself later on. Or maybe you design yourself and code yourself into a corner and you realize, oh, well, now that I've got to add this functionality over here, it's not possible with the design decision that I chose, the poor design decision that I chose in a previous phase. So I'm going to have to go back and refactor that and change that design so that I don't have to deal with that in the future. Or you deal with it and write more garbage on top of garbage on top of garbage until it all falls down. Technical debt means that if you don't do it right the first time, you're taking out a loan on your time in the future. And in fact, it's I think it's called a blind option, or so, I forget what I'm not a Wall Street bettor, so I forget. But technical a loan actually is not the appropriate metaphor to be used here, because a loan, you have very specific terms that you're paying 3% over 5 years or something like that. That's very predictable. But if you have a bad design, and you have an unpredictable, an unlimited amount of time later on that you might have to take out. That if you invest, the opposite of this would be that if you invest time up front, say, take 5 hours of time to think through your design, to whiteboard it, to bounce ideas off of your partner before you ever write a single line of code. If you flesh out all of the potential issues in that 5 hours, and then you start coding, and you don't run into any problems later on, you've basically saved time off the back end. So keep that in mind. You can look at this you should look at this as a resource. Your time is money. Your time is frustration. Your time is valuable. Don't shortchange yourself on that time. Looks like we got another question here. Is computer science 310 or 311? If you are a major, computer science or computer engineering major, take 310. 311 is for minors. So if you're seeking a minor, then 311 is where you want to go. 311, there's a little bit of overlap with 156 because the pathway for minors is you take 155. Generally, they take T, which uses Python, and then they go on to 311 rather than going into 156. But if you're a minor, you can take 311 and still count this course, I believe. But if you're a major, you have to take 310. Good question. Ancillary, but good question nonetheless. Remember also to speak with your advisor, and I believe, I could be wrong about this, but I believe that they now have a 4-year course plan in MyRed or wherever you go for that kind of stuff. We've had, in computer science, we've had a 4-year course plan for a good 8 years now, if you want to check it out on the advising page, where you can drag and drop courses. I wrote that a while ago now, 8 years ago, and the new one that is being used by MyRed looks suspiciously familiar. But go ahead and check that out, and you can. This is ancillary, but I highly recommend that you have a 4-year course plan, because there might be some really cool technical elective, like high performance computing or something like that, that's only offered every other year. Having a 4-year plan means that you can plan for that. Okay, well, I know that it's only going to happen in my junior year, so I need to make space for that. It also goes into something that is kind of related to what we're talking about here in professional environments. In a professional environment, I highly recommend people develop what's called a 5-year plan. A 5-year plan is like a near-term plan. Where do I want to be in 5 years? You're asked this in interviews all the time. Where do you see yourself in 5 years at this company? Well, I don't work here. I don't know, right? So you have to come up with some BS answer to give them. I see myself as the CEO of this country. Don't do that. But it is a good idea for you personally to develop that 5-year plan. In 5 years, I want to have risen to what would be considered a senior software developer in this company, or in 5 years I want to rise to a point where I can then go on move on to Google or something like that. But making that 5-year plan, it doesn't have to be formal. It just has to be a page of, these are my 3 goals. These are my top 3 goals. That gives you a roadmap in your life, in your professional career, on where to go next. And then, of course, you can revise that 5-year plan. You make a 5-year plan, and at the end of the 5 years, how well did I do? Well, that's no longer important to me, or that didn't happen. I don't care about that anymore. Right? You change as a person. You change in your career. Make a 5-year plan. Right? And in college, make a 4-year plan or a 5-year plan if you plan to graduate in 5 years instead. Okay. So back to more of the appreciations. The bad practices that you might have become apparent why they're bad practices. If you didn't do the design first, and just started coding and coded yourself into a corner without realizing it, then you saw the consequences of that later on, where you had to adapt your code, or you had to go back and fix it, refactor it, or you had to work with that bad design. That's why we call it eating your own dog food. If you make dog food and try to serve it to other people, they're not going to eat it. But if you eat your own dog food, then you're saying, okay, yeah, I'm okay with this. Sometimes it's used in policies, right? If there's a dress code policy or something, or if there's a work from a work on work over the weekend policy or something, and where a manager says, all right, everybody has to work from home this week because this weekend because the office space kind of thing. We're behind, but then the manager doesn't show up. They're not going to eat their own dog food, right? So it is a good indication that if they're not willing to do it themselves, it's probably not something that's justifiable. Okay. But everything down to from as small as poor variable names to over engineering. Remember Yagni, you ain't gonna need it, right? The most common Yagni thing that I saw was people making a class for a name, right? Rather than just having a first name and a last name, they made it way more complicated, or made an entire table for names, right? They made it way more complicated. There was something they're not gonna need, and they over engineered things. One poor variable name choice that I saw meant that they were caught in an infinite loop, right? And when I was helping these people through their code, I asked, well, what's that flag variable there for? It just says X. And they go, well, that's for if whatever condition that they were looking at. And I go, well, why didn't you call it that? And they go, so let's go ahead and rename that variable X to, has portfolios or whatever it was. And once they had that name, they immediately saw the bug, because the while loop should have been while they don't have portfolios or something, just the opposite. And they never saw that because it was a really poor variable name. Maybe it had a bad database design, and so there was an incongruity with your classes and your databases and your database tables, and you had to go back and fix it, right? Hopefully you have a better appreciation for the scope of a larger project, working and coordinating in teams, et cetera, et cetera. Overall, you're better coders. Overall, you're going to be better designers after having come up through this course. Right? In addition, oops, I went the wrong way there. Hopefully the impediments that you faced, that this is all agile terminology here, the impediments that you faced have now become apparent, right? The number one reason people have problems in this course and in all courses, not just computer science, but every course, is procrastination. Procrastination, waiting to the last minute, thinking that you're going to be able to do this huge amount of work and cram it into a small amount of time. You do this with tests too, that you think that you can cram right before an exam, and it turns out that you can't. Maybe it's if you can, then I'd question the value of the course to begin with. But hopefully you've come up with some ways of dealing with that. I've mentioned the Pomodoro technique before, where you're studying or you're doing one thing. You set a timer and you say, for the next 30 minutes, all the other distractions are gone. I am going to focus on this one thing right now. At the end of that 30 minutes, then you take a short break. You come back and you work on the same thing again for another 30 minutes, or you context switch out and you work on something else. That's especially true with software development, especially if you hit a bug, or if you hit a roadblock, or if you just have writer's block, right? Code writer's block in this case. Like, I can't think of how to deal with this. Walk away, right? Do that every so often, right? Okay, I'm going to stop thinking about this because my wheels are just spinning. Walk away, do something else, right? Do something else productive. And then come back to it. And a lot of the times, while you're doing that other thing, in the back of your mind, oh yeah, that's it, right? It'll just come to you as a moment of insight. But don't sit there and spin your wheels. Take time and do other things, and context switch out and look for a balance. Shamelessly stole this from Reddit, but I'll still claim it as mine. I always tell freshmen coming in, make sure that you sleep more than you work or study, or whatever you want to call it. Make sure that you sleep more than you study, work. Make sure that you work more than you party, and party as much as you can, right? And partying doesn't have to be, binge drinking or whatever. Partying can be, playing video games. Playing video games is recreation, any kind of recreation. Do as much as you can, right? But do those other two things in the hierarchy of things. You've gotten exposure to agile development, which again is meant to even out those high points of work where you're trying to cram, and then the low points afterwards, or building up to those high points. Don't work like that. Don't work with these peaks and troughs. You want to smooth that out so that you're working at a steady pace throughout the entire process. And you can only do that with proper planning, with proper design, with foresight and forethought on it. And hopefully, you also have a design first mentality at this point. The second most common impediment that we see with people, and again with this course, but also at large, is insufficient testing. This seemed way more insightful when I wrote it, but it doesn't seem way more as profound anymore. But if you can run code, you can run tests. Right? Nobody just writes a simple program, even if they're just reading in 3 variables and outputting their sum, right? You run it at least once with 3 variables, 10, 20, 30, and see that the output is 60, right? If you can run code, then you can run tests. It doesn't take much. If you can write code, you can write and run repeatable tests. If you can read code, you can write proper unit tests. Now, we got exposure to that last semester if you took 155E with CMACA. This semester, you got ancillary exposure to testing frameworks in Java JUnit. Hopefully you take that to heart as you move on. We didn't require you to actually write formal TDD, test-driven development, Java JUnit tests for every single little thing. It would have been a good idea, but we did require you to do like the second tier thing, where if you can write code, you can run repeatable tests. We required you to make test cases. We required you to make test data, right? Mock data. And run that so that you would have an idea of what was wrong, or it works or it doesn't work, right? Insufficient testing, not testing all possible values, not having a substantial enough test to be able to repeat a flaw in your code, to exploit for a bug to manifest or something. Those are some of the impediments that we saw by not writing sufficient tests, right? So again, at the very start of this course, rather than having the course description, I usually describe this course using the skills objectives. So at the end of this course, hopefully you can go down this bullet point list and say, yes, I've achieved those skills. You should be able to more easily pick up and learn a new programming language on your own. Again, this is something that you will never stop learning. You'll pick up a programming language every year for the rest of your life or something like that. At least, play around with it. At least have a Hello World program and, compile it and then play around with it and print out the sum of natural numbers or something in that programming language. Be able to recognize, use, design, and appreciate programs, with an object-oriented flavor. And going back to bullet point 1, by the way, it's not necessarily that you will learn new programming languages, but for example, Java. Java has been updating every 18 months for the last several years. New stuff is introduced in programming languages. No programming language, unless it's dead, is completely static. Even C is updated every 10 years. Very, very conservatively, but it is updated. So languages change, languages evolve, new features are added, and you should always be updated on those so that you can say, oh, okay, well, this is a great new feature. I'm glad that they put it in, or this is a terrible new feature. I'm not going to use this. I'm going to avoid it. And with Java, there are plenty like that, right? Going back to the third bullet point here, you should be able to design a database-backed application from scratch given a general problem statement, right? We gave you a general problem statement. And that's exactly what you did in phase 3. You designed a database for it, right? You were able to understand and implement basic data structures, as well as recognize how and when to leverage the appropriate data structures. We looked at how to implement several data structures throughout this course. In practice, you never do that, right? You don't roll your own. You use an off-the-shelf data structure. And being able to recognize which data structure would solve the problem for you, or with very little effort solve the problem for you, very little glue code added on to that, that is a true skill, right? That allows you to not have to write thousands of lines of code to do something. You just pull out a data structure that you know is efficient, that is appropriate to use, and does what you want, and then now it's a few lines of code, as exemplified by heap sort. Put stuff in, take stuff out, and it's magically sorted. Right? You leverage the smart data structure there. Also, you should be able to identify and analyze basic algorithms as you go forward through the curriculum. In real life, here's a dirty little secret. In real life, your employer's never going to ask you to give me the big O analysis of this code, right? Your colleagues will, though. When your colleagues realize that you are using a linked list and iterating over it using an index-based find method, that's going to be very apparent that that's a design flaw and that's a huge inefficiency. So make sure that you at least understand it. That not necessarily that you're going to do that a lot in real life. In the curriculum, you might continue doing that, especially in computer science 3 or advanced data structures and algorithms. In real life, you're not going to have to present a big O analysis, but you will need to understand that's a terrible algorithm because it's order n squared, or that's a terrible algorithm because it's going to be exponential, or that problem there is NP complete, right? We're never going to be able to solve it directly. That's something for, say, the next class. So let's look for a heuristic instead, right? That's all encapsulated again in one of the quotes I really like to put forward. One of the themes of this course is that smart data structures and dumb code are a lot better than the other way around. That's from Eric S. Raymond, who wrote The Cathedral and the Bazaar, which is a collection of essays on software development, kind of the philosophy or treatise on software development. I highly encourage you to read it. It's maybe a little bit dated now, but some of the principles are still very much relevant. By the end of this course, you should be able to approach a reasonably complex problem and ask design questions first, right? In contrast to Computer Science 1, where you design a top-down solution until you get down to just, I can do this one line of code. You should be asking yourself, what entities or objects would be appropriate to model this problem? What would how would the objects interact with each other in order to solve this problem? And what data structures would be the most appropriate or efficient to use to solve this problem, right? Basically, again, it all boils down to programmers are lazy. Software developers are lazy. If you can get something done in 5 lines of code by using a pre-existing library and a few data structures, you do it, right? If you can automate something so that you don't have to do manual data entry every single time, you do it, right? Because we are lazy and we like to go and read books or play video games or do something else, basically, right? So the big takeaway from this is that you may have done some or a lot of things poorly, but next time you will definitely do better because of this experience. Another question here, can we review different scenarios where we might be want to consider using different particular data structures covered in class? Good question. If for example, a hash map, right? A lot of people, what I saw was they wanted to they had to search for a particular portfolio, so they used a list to store a bunch of portfolios. To find a particular portfolio based on the portfolio code or the identifier, they had to iterate through. They had to write their own code. They had to roll their own code to iterate through. Check, is this it? Is this it? This it? In other words, they had to do linear search, right? And that's because they were using a list. What we suggested a lot of people do, and the ideal solution was to use a map, where you mapped the code to a portfolio, right? And in particular, you used a hash map instead, so that this lookup was instantaneous. It's amortized constant time, so that you don't have to roll your own. And is this it? Is this it? Is this it? No, you just simply map a string to the object that represents the entity, right? And then all the heavy lifting is done by the map itself. You put stuff in, you take stuff out, right? Another scenario would be, well, I really love hash maps. I really love hash tables because they offer, you can put stuff in efficiently, amortized constant time. You can retrieve stuff efficiently at amortized constant time. But there's no order, not necessarily an ordering with it. So what if I wanted to sort that? What if I wanted to iterate that through all portfolios based on their value, right? A hash map is not going to be an ideal data structure for that because they're all over the place. Their intention, the purpose, the use case of a hash map is for easy and efficient storage and retrieval, not storing things in an ordered manner. If you want an ordered list, then you need to look towards a binary search tree instead, and in particular, a balanced binary search tree. If you need to be able to search for things efficiently based on some criteria other than how they're stored, then a binary search tree is perfect for that. You can put stuff in, you can take stuff out, not in amortized constant time, but in essentially a logarithmic time, right? So it all depends on what you're storing, how you're storing it, and how you want to interact with it. And sometimes you use a combination of these data structures, right? So, and just to give you a preview here, you know what? Let's go ahead and look at it. No, okay. So, 310. Somebody already asked what is Computer Science 3. It's a CSE 310. Let me go to my documents here because I always put themes, quotes in my syllabi for the course. And one of them here, I'll give it to you right here. If you want to be a good programmer, you just program every day for 2 years. If you want to be a world-class programmer, you can program every day for 10 years. Or you could program every day for 2 years and take an algorithms course. That's the theme of Computer Science 3 there. Again, it kind of goes into smart data structures and dumb code are a lot better than the other way around. Being able to recognize patterns and saying, oh, I can model that as a graph, and I could then, I've got 50 different graph algorithms that I could throw at it and solve this problem, right? That kind of stuff comes with experience. There is a bake-in time. Even with just basic programming like Computer Science 1, you still need a bake-in time. You still need a exposure, then reflection, then iteration, and then exposure to another topic that builds on top of that. You do need that time to process the ideas. And hopefully a 15-week course or a first-year computer science curriculum does that a little bit, but of course that's why we've got 4 years, right? There's still you still build on top of your knowledge, and you do that through the rest of your life. So again, course conclusion here. There is no final because of the move to remote learning. Everybody got those points, but you can also still get additional points by filling out that course evaluation. Make sure you do so before Sunday. Assignment 8 is your last thing to turn in. That is due Friday at midnight. Remember, it's all written, so if you're already writing it by hand, we've given you several options for scanning that and making sure that it's a PDF. The final stats will be posted on Piazza, along with, of course, hopefully later today we'll have assignment 7 and the design document assessments out, along with a retrospective on those. But otherwise, when the course finally concludes next week and final grades post, I'll also give final course retrospective, at least the statistics of how well everybody did, of how well the course did overall. It looks to